Hello students, the purpose of this video is to get you comfortable working with exponential functions as well as logarithmic functions and converting between the two. So we've talked about in a previous video that there is a relationship between logarithms and exponents. If you look at your screen, I currently have several equations written on the left-hand side that are written in exponential form. You'll see each of them has a base of 5, and I'm asked to raise it to the x power, and I want to raise it to a power so that I get the following solution. So for example, 5 to the x equals 5. What would I need to plug in? I would need to plug in 1. Well, not all of these values are easy to see. If I have 5 squared, I can tell that I easily get 25. And if I get 5 cubed, I can easily tell that I get 125. But to get 20 and 60 is not so easy to see. In fact, it's not going to be represented by a whole number. And that's when logarithmic functions come in handy. If x and b are positive real numbers such that b does not equal 1, then y equals log base b of x is called the logarithmic function base b, where y equals log base b of x is equivalent to b to the y power equals x. So this is the part that you want to concentrate on. Y equals log base b of x is logarithmic form, and the base from the log becomes the base in the exponential form. The answer to the logarithmic is the exponent of the exponential form, and then the argument becomes the answer of your exponential form. So that brings in some important vocabulary words. So we have the logarithm, we have our base b, and then the thing that is inside of the logarithm is called the argument. And again, the reason why we're learning about logarithmic functions is because there is a relationship between logarithmic and exponential functions. They are, in fact, inverses of one another. So if you look at this graph here, you see the line y equals x. And as we discussed in one of our previous sections, inverses are reflective across that line. And so you can see my exponential function is the blue graph, and its inverse is the logarithmic function, which is in pink. So write the following equations in exponential form. So each of these are given with log base b of an argument is equal to 4. So log base 2, or log base 10, or log base 7. The arguments are as follows. 16, I'll do the arguments in green. 16, 1 over 100, and 1. And then, using a calculator or thinking through, you can get their solutions of 4, -2, and 0. So if I want to go write these in exponential form, if I look over here, I can see that when I have a base of 2, in exponential form, the base is also 2. When I have an argument of 16, that represents the answer in my exponential form. And then the answer from logarithmic form represents the exponent for exponential form. So you just want to go through each of these and become comfortable with understanding that the base of a log is the base of an exponential form. The argument of a log is the answer in exponential form. And the answer in log form is the exponent in exponential form. And you'll see that that follows for letter B and for letter C. You can also go backwards, so you can write an equation in logarithmic form. So I start by giving you exponential form, and same idea. So the base of your exponential form represents the base of your logarithm. The exponent of your exponential form represents the answer of your logarithmic form. And then the answer of your exponential form is the argument for the logarithmic form. And you'll see that that follows for B and C as well. So you just want to make sure that you're feeling comfortable going from exponent to logs and from logs to exponents. Now there's two types of logarithms that we have. We have common logarithms as well as natural logarithms. Common logarithms are using the word log, and they have an understood base of 10. Whereas natural logarithms utilize the word ln, and they have an understood base of e. And keep in mind, we've learned about E. It is Euler's number. It's represented by like 2.7 rounded. But a natural log will be written like ln of 2. And again, it has an understood base of E. And logs will be written as log of 2, and it has an understood base of 10, even if you don't see it there. Now, I do want to talk about the equivalence property of exponential expressions. So if b, x, and y are all real numbers, where b is greater than 0 and does not equal 1, then if you know that two things with an exponent are equal to one another, then you know that their exponents have to be equal to one another as well. So this is not the correct example, so let me get rid of that for a second. So what this is saying is if I know that I have 3 squared and that has to equal 3 to the x power, then because their bases are the same, I know that their exponents then need to be the same as well. So x must equal 2. And that's going to come in handy as we go through our properties and logarithms and work through some problems. So I'm going to pause the video for a second, and I encourage you to jot down these properties. They're not anything that's too crazy. These are honestly and truly some shortcuts to recognize. So the idea that anything raised to the 0 power is going to equal 1. So if you see an argument of 1, then you automatically know the solution to the logarithm must be 0. If you see the same value for your base and your argument, then you automatically know the solution should be 1. Those are the two that you'll use the most frequently, but you're welcome to jot down number 3 and 4 as well. Looking at graphs of exponential and logarithmic functions, again, we can notice a lot of similarity. If you look at the exponential function and then you imagine tilting it 90 degrees to the right, then you would get the logarithmic function. So it just appears very, very similar. And again, this makes sense because these are inverse functions of one another. As always, I hope you found this video helpful. If you have any questions or concerns, please don't hesitate to reach out.